The mole is a counting number. Just like the word dozen always means 12, 1 mole, abbreviated MOL, is always representing 6.02 times 10 to the 23rd of the items. A dozen is 12, a mole is 6.02 times 10 to the 23rd of whatever it is you're talking about. When we're talking about atoms, a mole of atoms is 6.02 times 10 to the 23rd of those atoms. It's a count. While this is useful, it's not as useful as being able to relate the amount of atoms you have in the laboratory to its mass or its weight. We have balances in the laboratory to weigh things, and so we want to be able to relate the mass or the weight. You might have asked yourself before this, why in the world did they pick 6.02 times 10 to the 23rd to represent the mole? Just like why did they pick 12 to represent dozen? There's a usefulness to it, and the usefulness is that as we think about that atomic mass, which we talked about previously, which is written on the periodic table below the symbol, the atomic mass, which is the weighted average of all the different isotopes, that atomic mass in AMU can be equated to the mole if its units are grams. That sounds a lot more complicated than it is. It means 1 mole of boron atoms will weigh 10.81 grams. So 1 mole of boron would be 10.81 grams of boron. 1 mole of carbon atoms would be 12.01 grams of carbon atoms, rounded to the second decimal place as indicated on our periodic table. 1 mole of iron atoms would weigh 55.85 grams. So we have another equivalence for the mole, which is very, very useful for converting units. This is an equivalence which will convert between grams and moles, and that equivalence is one you might want to keep handy. 1 mole of X, whatever atom it is we're talking about, is equal to the number of grams of X as looking at that atomic mass on the periodic table. So if I look up the atomic mass on the periodic table, that's the number of grams that equals 1 mole. So I can use that to convert between grams and moles for something. So for example, let's work a problem. Let's say, how much does 2.3 moles of magnesium weigh? Or what is the mass of 2.3 moles of magnesium? A mass, a weight, you're looking for grams. You have to recognize that that's the unit you're looking for. So question mark, grams of magnesium equals 2.3 moles of magnesium. That's how we start our problem, and it is a unit conversion problem, so we'll put times in our ratio sign. We'll put the unit of moles of magnesium on bottom so that it cancels, and we'll put the unit of grams of magnesium on top, so that we'll be left with that unit when we're finished setting up the problem. And to equate grams and moles, I come up here to my equivalence between grams and moles, and the 1 goes with the mole, and the number that goes with the gram is the molar mass, or I'm sorry, the atomic mass from the periodic table. 24.31 grams goes on top. I punch this into my calculator. I'd punch 2.3 times 24.31. I would round my answer to 2 sig figs. This number has 4 sig figs, this number has 2 sig figs. So I would round my answer to 56 grams of magnesium. So if I know how many moles, I can calculate how many grams by setting up the problem in this fashion. Alright, we can also go backwards. We can go between grams and moles the other direction. Let's get a little space. For example, might ask the question, alright, how many moles would 5.32 grams of aluminum be? If I have 5.32 grams, how many moles is this? For aluminum, I come down here and find aluminum on the periodic table. Its atomic mass is 26.98, so there's my equivalence. But I'm going to set the problem up just like all the unit conversion problems we've worked on before. Question mark, moles of aluminum equals 5.32 grams of aluminum. Times, and my ratio sign, grams of aluminum on bottom, put your units first, moles of aluminum on top, and then come up here to look at my equivalence. The 1 goes with the moles. The number that goes with the grams is from the periodic table, so I put the 26.98 on bottom. My grams of aluminum cancel, and I punch it in my calculator. 5.32. I'd hit divided by the 26.98 because it's on bottom. This number has 3 sig figs, this number has 4 sig figs, so I'll round my answer to 3 sig figs, and I get 0.197 moles of aluminum.